Okay, this is my Mr. Sonnenberg here, Bentley Junior Senior High. My first screencast. We're going through Science 9, the unit Matter and Chemical Change. And today we're going to talk about specific outcome 1.4. And basically what we're going to be doing is looking at ways we can distinguish between physical and chemical changes, and we can evaluate whether a new substance has been produced or if there was just a state change. So, moving on. The first thing we're going to discuss is these changes in matter. So, what is matter? Well, matter is anything that takes up space or it has mass. Now, matter can change from one form to another, or we can create new materials. So last class we talked about properties, physical and chemical, and matter has its own distinguishing characteristics. So, and we can distinguish all this matter based on its physical and chemical properties. So these properties, these are its characteristics, and they're basically going to describe how it behaves. So we know physical characteristics. Typically, we can observe hardness. We can observe the color. We can measure quantitatively. We can measure its boiling point and its melting point and its density. Whereas chemical properties are things such as how it reacts with air or how it reacts with other pure substances, water, oxygen, and such. Physical and chemical change. Oops. That's a change that matter it can undergo. And there's two classifications of these changes of matter. There's physical change and chemical change, and we're going to start with physical change. Now, this occurs when a material changes in form but not in composition. So basically, I'm going to use the example of ice, or I mean water, and we're going to start with water in a liquid state. And what happens to the water is when we decrease the temperature, the process of freezing occurs, and the water then turns into a solid. Now, again, we're viewing a physical change because in terms of quantitative change, physical change, we can establish that what is water's freezing point? Well, we know it's 0 degrees Celsius here in Canada. Now, again, what's happening is the particles are becoming closer together with this change because the particles are slowing down. So we've learned about the particle model of matter and such, and we can understand that now it's turning into a solid state. It does not mean that the water has changed in composition. It's still the basic composition of water. It's just in a different state. Now it's solid because the particles are packed closer together and they're moving slower. There's less space in between the particles. Now, if we were to take that liquid water and we were to heat the water, and again through quantitative measurement we could say that we've reached its boiling point, 100 degrees Celsius. Now what happens is it turns into water vapor. Now this water vapor, okay, is in a gas state. So now we have H2O gas. Again, it hasn't changed in composition. It's still H2O. It's just in gaseous state. But it has just changed forms again. It's changed states. So that is a physical change. So we haven't created any new substances. All we've done is we've just changed the form of the substance itself. And we just changed its state. So this change isn't permanent. This change is something that occurs, and when we see it, especially in Canada with our cold winters and such, we see the melting and the freezing. And where does the snow go? Well, it melts some of it to run off and underground, and then the rest can evaporate. And then it comes down when it's condensed. And again, you learned the water cycle in grade 7, so you can understand that process. This process of changing of states occurs all the time. So if we take a look at the diagram, the red arrows are going to indicate that energy is being absorbed. So it's getting hotter. And the blue arrows are going to illustrate that substance is getting colder, therefore it is giving off energy. Okay, so we start with the solid, which would be our ice. And if we increase the temperature, what happens is the particles spread apart, they move farther and they turn into liquid, and we get that melting that's occurring. Now, again, with the liquid, we increase the heat again, we get that process of evaporation, thus turning the liquid water into a gas, H2O gas. Again, heat is being absorbed here, energy is being absorbed. Now, if we were to cool, take a look at the blue arrow, right here. Now what's going to happen is this gas is going to be cooled, particles will become closer together, and they're going to condense. So that's a process of condensation, thus turning the gaseous water into H2O liquid, which we have right here. And again, it's losing, it's not absorbing energy, it's losing its heat energy. And then same process here with freezing. Again, particles becoming closer together since we know about the particle model of matter, and then turning into ice again. Okay, so now let's talk about chemical change. Okay, sometimes it's difficult to distinguish between physical and chemical change, but there are some signs that we're going to learn through this next section that are going to help you to identify and distinguish between the two. So a chemical change, this is when two or more substances react and they create one or more new substances. So it's not always difficult, or it's not always permanent, but in most cases it's a permanent change, and it's difficult to reverse this change. So an example of this is combustion. So how can you identify a chemical change is occurring? Well, this again, like I said earlier, it's difficult to decide if it's physical or chemical. Has it changed in state, or has it completely changed in composition? So what happened is now we can look at specific forms and clues to help us decide if this new substance has been formed. And that is the key, is there evidence that a new substance has been formed? If so, then now we have a chemical change which has occurred. So again, we can use the following clues, and I'm going to discuss these clues, and we can decide if a chemical change has occurred or not. So again, identifying this chemical change. 1, was there a change in color? Example of this could be statues that were created, and if anyone's traveled or seen statues, sometimes they turn a greeny color, or in my experience I've seen this, and they change color. Is it easy to reverse? No. Is that change permanent? Somewhat. But that change in color, a chemical change has occurred, and we can tell because the statue wasn't that color, and it was its reaction with oxygen in the air. Okay, change in odor. Has a change in odor occurred? Is it giving off a foul smell, or well, maybe a pleasant smell, but is it giving off a different smell than it was at the beginning? Formation of gas. So this right here is a good sign. Is it bubbling in a liquid? Okay, well that can symbolize that a gas is forming in that liquid. That's what those bubbles are. Formation of a solid. Now a precipitate in the liquid. Okay, so is this solid forming in the liquid, this precipitate? Okay, another sign. Release or absorption of energy. Is there a release of heat? Is heat being given off? Heat energy. And we can tell, especially when things combust, we can tell that heat is being given off, and we can feel that. We know that a chemical change is occurring. The materials you started with are used up. So what you started with is now gone. A new material is formed. Okay, what I started with now looks completely different, and it's a new substance being formed. And then the changes, obviously, I've said this a few times, the change is difficult to reverse. So these are 8 signs and characteristics that we can use to identify whether a chemical change has occurred. Okay, so Basically what I've done is I've put a couple resources. The first resource is a text resource you can click on, and it's going to provide you with some examples of physical and chemical changes. Several different examples actually that are going to outline whether a change of state has occurred, which is physical, or whether a new substance has been created, and it's going to identify various examples of those 8 criteria that were outlined that were going to help us distinguish whether it was physical or chemical, or that a chemical change has occurred. And then last was a YouTube video I found that I think is a great resource because it shows a lot of visual images and such. So it's about 3 minutes long, and it's also going to help you to better expand on your understanding of the topic. Okay, well, thanks for listening. I hope this screencast is something we can continue. I've enjoyed doing it, and I hope it helps you to expand your learning and your knowledge of the subject that we're covering.